Okay, so yes, we're going to be taking a look at the Juniper security devices this term. We are so let's just get in and have a look at that. First of all, what I want to do is let's just get into what we're going to talk about today. In our first lesson, we're going to be describing traditional routing, and really what we want to do, just to start with, what I want to do is I want to compare routing, a router with a firewall, or just contrast the difference between what a router does and what a firewall does. And we're going to take a look at some of the trends in internet networking, look at an overview of Juniper's operating system for the SRX series, which is the device that we are using. It's the device we have been using actually last term as well. And we're going to look at the logical packet flow, what happens as a packet goes through this particular device. So let's just a bit of a recap of routing and what a router does. So here we have a router out there on the internet. What is its job? What is it doing? Well, its job is to forward packets based on a layer 3 IP address. So essentially, it's going to use some kind of path determination mechanism. Typically, it's going to look at the destination IP address. It'll do a lookup within its routing table, and then it will decide which interface it's going to forward that out. So packet processing is stateless, in other words, and promiscuous. In other words, what happens is it doesn't really take into account that packet relationship to any other packet. It doesn't take into account whether that packet is part of a communication session from a particular point to a particular point, between particular servers, or between a particular client and a particular server. It doesn't take into account any of those things whatsoever. It just looks at that packet, looks at the header information, and makes a forwarding decision based on that information. So also promiscuous in that it forwards everything. It doesn't care. It doesn't discriminate. It will forward anything and everything that comes along as long as it has got forwarding information in its forwarding table. So routers, what do? Well, they'll separate broadcast domains, as we know, and they also provide WAN connectivity. So let's take a look. IP packets are forwarded based on their destination address. That is the usual way of forwarding packets. They maintain a routing table, as we know. We use static routes, or we use a routing protocol, such as RIP or ISPF or maybe BGP. So, as we know, routers will, here we are, the packet arrives on an interface, it does a lookup, looks at its routing table, and then forwards it out another interface and uses the longest prefix match to figure out what is the best interface to forward that out. So these are things that we covered last term. So this is nothing new. So a traditional router provides stateless connectivity. So it forwards everything, absolutely everything that it can forward, it does forward. Operates at layer 3, cannot detect security threats in higher layer protocols, doesn't really look at anything. So the point of a router is to forward traffic as fast as it can. All right? What we're interested in is speed. We want to get traffic through the internet. We're going to provide connectivity, and we want to provide that connectivity as fast and as efficiently as we can. Okay, so a router's goal is to get connectivity, but it's also speed. We want to forward that traffic. We want to do that lookup. We want to forward that traffic and then get on to the next one. Okay, so that's really what we're interested in. Those routers out there on the internet, we want to get that connection, get that traffic going as fast as we can. That's really what we want out of our routers. We want performance, we want speed, we want connectivity. We're not really interested in all the intricacies of what's in the traffic. We don't really mind what's in the traffic. We just want to forward the traffic. So a router operates on each packet individually, can't detect malformed sessions. It's not, we don't want it to be spending time looking at those things. That's not what it's there for. So the issue is the network is immediately vulnerable. So basically, here we've got the internet, here we've got these routers forwarding everything and anything that comes along as fast and as efficiently as it possibly can. Now, when that traffic arrives at your organisation, do we want to take whatever comes along? Do we want to take absolutely anything and everything that comes along that hits our enterprise and just forward that straight through into our enterprise? Absolutely not. Okay, when that traffic arrives at our particular enterprise, we don't want the router type functionality to say, well, I've got a packet, I've got information in my routing table as to where to send it. Boom, let's just send it. Bang, let's just send that on. And away we go, next packet. No, we don't want that to happen at all. We want to be very picky about what we let into our private network. We're going to be very, very picky about what comes in to our enterprise. Okay, so what we're looking for when it comes to traffic into our enterprise is a very different situation. So here's our typical router situation. We might have an enterprise head office, so we've probably got this traffic coming through between our offices, from the internet, from other sources in the internet as well, from other servers that may be out there on the internet, all coming through into our branch office and our head office. So let's take a look at how this idea of a firewall, which is the device that allows us to be really, really picky about what comes into our enterprise. This is where we get to say what comes in and what doesn't. So let's take a look at how these firewalls kind of started out, traditional firewalls, standalone firewalls. So when firewalls were invented, they were a separate device. It was like, okay, there's my router and there's my firewall. So you come along and you install your firewall. So it is a standalone device, and as these enhanced security capabilities into the enterprise, it must perform stateful packet processing. Remember that the router performed stateless packet processing, whereas a firewall performed stateful packet processing. What does that mean? What is the difference between stateless and stateful? Okay, well, stateless, it looks at the packet as a packet. It doesn't take into account any relationship of that packet to any other packet. It doesn't say, well, this is part of a communication flow between one point and another point. It doesn't take that into account at all. That's stateless. Stateful, however, does take that into account. It takes into account that a packet is actually part of a particular communication process that's going on between 2 points. It takes it into account. It looks at that as part of a process, part of a communication flow between one point and another point, and then there's return traffic coming back from that point to the originating point. So it looks at packets in relationship to the communication session that they are a part of. It keeps a session or state table based on IP header and high level information. So we're looking at high level information being, of course, layer 3 IP header. We've got TCP UDP up there at the transport layer, layer 4. And then we've got application layer stuff as well, okay, up there at layer 7. So it looks at all this information, the header, so source address, destination address, protocol that's being used, application layer, ports that are being used, looks at all that information and decides this packet is part of a particular communication flow based on that information. What else do firewalls do? Well, they do NAT and PAT. NAT being, of course, network address translation, and PAT being port address translation. Okay, so they do NAT and PAT, private to public and public to private address translation. Okay, so that typically is a firewall function. Of course, routers can do that, but typically you want it happening in our firewall. VPNs, again, is typically a functionality of a firewall where we want to put in this encryption, this authentication in place where we are setting up a secure private network between, say, this particular site and another particular site within our organisation through the public internet. We can also do other things with firewalls. Certainly, well, SSL, secure socket layers, but IDP stands for Intruder Detection and Prevention, which is a way of analysing traffic to say, hang on, this looks like we're being hacked. Based on what I'm seeing in this traffic, this looks like we could, like the series of things that I'm seeing looks like a hacking attempt. ALGs, which stands for Application Layer Gateways, which are designed, again, to provide. Now, before introducing the concept of zones in this slide, we'll get into zones in quite a bit of detail as we go through. So, the idea here is, however, that we've got, just looking at this slide here, we've got two zones. We've got a zone called an external zone, that's where we want to sort of be very careful about what we let in. So, what we look at here, what our stateful firewall is going to look at, is things like the source IP address, destination IP address, the protocol, source port, destination port. So it's going to look at those pieces of information. So there's 5 pieces of information there. And it's going to say, okay, we've got traffic that's going through that has got the same source port, same destination port, using the same protocol, same source port in my layer 4 and the same destination port in my layer 4. So that traffic that has that commonality is part of the same session, part of the same what we call a flow. And then it gives it a session token, and that is what we call a flow. Okay, so in a stateful firewall, a flow is constructed based on analysis of the traffic where these things are exactly the same. Okay, so what we then have is a session table. So it says, well, hang on. Here I've got traffic which is originating from my internal network. It's going to my external network. It's using protocol number 6. What's protocol number 6, by the way? TCP, right? TCP. It's using protocol 6, TCP. Alright, it's going to destination port 80. Alright, so it's web traffic. And what it does is, okay, I'm going to create a session table that says there is the traffic that I've identified. It's going out on a particular interface. And it says, well, if I've got traffic that's going, and then it looks at, it will actually create this flow. We'll look at this in more detail later. But it says, is this traffic allowed? That's kind of a decision. Am I allowing traffic to come from inside my network out to that particular internet address? Well, you probably are, because it's probably just internet traffic. And so you say, okay, well, if I'm allowing that traffic to proceed, then what I should be expecting is some return traffic coming back from that IP address on that same port 80, going to the originating source address, to the originating source port, using the same protocol. So, this is how stateful firewall works. Is if I'm going to allow the traffic out to that endpoint, then I'm going to also allow automatically the return traffic back as well. Okay, so a stateful firewall will look at a situation where a connection is initiated from within the private zone. If that connection is permitted, then it will also permit the return traffic that comes back to that or to form that particular connection. So that is like the essence, the basic fundamental operation of a stateful firewall. Okay, so the key thing about a stateful firewall is, where is this traffic initiated from, and is it permitted? Okay, that are kind of the two things. Is this traffic permitted? If it is, then I'm going to allow the return traffic as well. Okay, so we have this thing called a flow there. And the outgoing and incoming packets will use the session table for bidirectional communication. So we will already set up a firewall session that allows for the expected return traffic. Alright, so that's one of the things that a firewall does. That's kind of its most basic functionality, a stateful firewall, is to set up a flow. Now, the other things that a firewall will do is Nat and Pat. We did cover this when we did our CCNA, if you remember back there. But essentially, what we can do is we can take a source port address, translate that to a destination address or a source address. Either way, we can do source NATing, destination NATing. We can take a source address. Most commonly, we do translate that into a public source address so that traffic can be forwarded out onto the public internet. So NAT converts IP addresses, PAT converts TCP and UDP port numbers, typically used at the boundary between the private and the public networks, as we know. So that's generally the firewall function as well. Another thing that we are interested in doing with our firewalls is creating virtual private networks. So we have looked at this concept of virtual private network before. We have discovered that there are actually many different types of virtual private networks. In this particular case, we are interested in an IPsec type VPN. Now, IPsec stands for IP security, and it is a protocol which allows us to have secure communications between two endpoints. In this case, what we're interested in doing is setting up secure communication between one particular site and another particular site. So we might have head office, branch office, or a couple of branch offices, and we need to set up communication between the two. We will configure our firewalls to provide that IPsec VPN connectivity from one firewall to another firewall, effectively connecting our two sites. So we're really effectively connecting the networks in one site to the networks in another site across this private link. Which really means that all the users in one site can potentially access whatever resources, whatever network resources, servers, etc., whatever's over there on the other side, or can make, say, VoIP phone calls across that link using unified communications networks, etc. So it really does connect those two sites together. So a user over here can make a phone call to a user over there across that VPN, for example, or could access resources on servers, etc. So it provides full site-to-site connectivity, and the point is that it is secure. Okay, so we'll get into later on, we'll get into a fair bit of detail into how IPsec works, but we do have a situation where we're doing encapsulation to provide the actual private network across a private connection across a public network. That is a process of encapsulating the packet with a different additional header. We also encrypt that information, and then we authenticate the information. So encryption means that If anybody intercepts it, well, they can't read it. Authentication means that we actually verify the endpoints themselves to make sure that we think we're talking to this endpoint, but are we really talking to that endpoint? That's authentication, is make sure that we are really establishing connections with the endpoint that we think we are. So that's the authentication part. We'll get into this in a fair bit of detail. So whereabouts in the network does the firewall go? Well, here's a few different scenarios here. Let's look at our little, down the bottom here, a little home office, a little retail site. Our firewall pretty much just sits there on the edge of our network and provides connectivity to the internet and VPNs to other sites as required. Over here with our branch office, similar sort of situation, hooks into a switch there. Also with our bigger sort of head office here, we've got this router, and our firewall then sits behind our router. So the traffic comes in to our router, and then our firewall takes care of it from there. So that's kind of traditional firewall positioning. This is where we've got the firewall concept as a separate device. This is, for many, many years, this is exactly how it was done. However, what we're doing with our SRX is really doing it a little differently. Let's just go back to that slide here. What we're doing with our SRX is we're kind of combining this router and the firewall into one device. Okay, so our SRX is going to handle both of those functions. Right, so that is just gives us, I guess, a more economical and much more capable way of managing our traffic at the edge of the network. We'll take a look at this architecture. So let's take a look at contrast the router. So on the bottom we've got traditional routers start off as completely vulnerable, which means that they forward absolutely everything. Now you can restrict that with things like firewall filters or access control lists to kind of lock that down, but basically they forward everything by default. On the other hand, a firewall starts off forwarding nothing. So basically it's totally restricted. So it's saying, well, I'm not letting anything in at all, zero. So the beauty of the firewall is that you may say, well, look, there's actually 3 or 4 things that I do need to let in to make things work in my organisation. Like, for example, I've got a unified communications server in my organisation. If I'm ever going to have anybody make a phone call into my company, I've got to let the phone call in. So I've got to let the SIP protocol through my firewall to get into my communication server. That has to happen. So I've got to let that in. There might be other things. Maybe you've got maybe a range of different things that you want to allow in. So you might say, well, look, there are a few things I need to allow in. 3 or 4 things that I need to allow in. Okay, so what you can do is you can say, I'm going to allow that, 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 and that. Finish. Okay? Because if I have a router, I might have 3 or 4 things that you don't want. So a firewall starts off with saying, no, nothing is allowed. You say, okay, well, actually, I want to allow a few things, and you can then configure those. You can open up ports to allow those things in. It's kind of the way that we approach the firewall situation. Okay, let's look at the platforms that we're going to be using here. We are using the SRX device. It is the Juniper Security platform. They come in various sizes, various capabilities. There are the smaller ones, which are designed for the branch office scenario, and then there are some massive ones which are designed for very high traffic situations and lots and lots of ports. So we're using the branch office type for what we're doing, and this is where they excel very well in that particular role. Okay, so they provide both routing and security. So we've got this high-performance firewall derived from the ScreenOS software. Junos had a dedicated firewall device. It used a software called Screen Operating System. What they did, they took the capabilities of that firewall and integrated it into their Junos operating system which we are using on the SRX device. So as we go through this course, we're going to be configuring what's known as screen options, which really are the capabilities of this firewall, the Screen OS firewall. We're going to basically configure those options into our Junos SRX device and look at what that is and what they do. They basically are hacking defenses. So we'll look at that as we go on. We're also going to be looking at zones in a lot of detail. We're going to look at security policies that we can put in place between our zones. We'll also be looking at IPsec VPNs. We'll get into the detail of how they are set up, we'll have to configure those and look at how they are working. And we'll do also look at and configure intruder detection and prevention as well. Okay, so we looked at this little graphic before, being that the Junos operating system is modular. It's got all these different components that run. They run in a separate address space. That makes it very efficient. So Junos is the base operating system. We're going to be using session-based forwarding. We're going to be using some of these Screen OS-like security features. We still, of course, as we are quite aware, we've got a control plane, operating system running in our control plane. We've got routing protocols and we've got forwarding features. This device, by the SRX device, can operate in two different modes. It's kind of important to understand this. It has what's known as packet mode, and then it has flow mode. So when it's in flow-based mode, it is operating as a security or as a stateful firewall filter, which is a security device. When it's operating in packet mode, it's pretty much just a router. So we have the ability to switch the device from packet-based mode to flow-based mode or session-based mode. The capabilities of the device are really used fully when it is in session-based mode, it's operating as a firewall filter. So to date, we've been using the SRX devices, but we've been using them in packet mode because we've just been studying routing. Now we're going to study security, and we're going to switch it into flow mode and use it as a security device. So there are things that we need to be aware of in this mode that are different to how we use it in the other mode. Okay, so even in security mode, we can still, if we want to, isolate some traffic and treat it as purely packet-based mode, in that we don't really go through the stateful process with it. It is possible to do that. So the packet-based features, we can still use packet-based features in that we're using routing protocols, forwarding features, stateless filters, polices, class of service. We still get all of that. With the session-based features, we get to implement these Screen OS features, which are really anti-hacking features or hacking prevention capabilities. We go through a process where we do a first packet flow. We'll get into this and look at this in a bit more detail. We'll do a first packet flow, which creates the session, sets up the session based on that information that we looked at before: source and destination IP address, source and destination port, and protocol. And protocol basically tells us what does protocol does. What's that protocol information again? Protocol tells us whether it's using TCP or UDP. Okay? And port number for TCP is 6. What's the port number for UDP, by the way? Anybody? 17. Okay, UDP uses port 17. Where is that information, by the way? Where would I find that information? Where is that information recorded in traffic? It's actually recorded in the header, in the layer 3 header of the IP packet. Okay, it will tell you whether that IP packet is using TCP or UDP as its transport layer. Information is bound. Okay, zone-based security features. So, packet on the incoming interface associates with the incoming zone, and a packet on the outgoing interface associates with the outgoing zone. So essentially we're saying, well, if packet's coming in on this interface, it's in one zone, going out on that zone, am I actually allowing that traffic to go from this zone to that zone? And look at that. They are based, that decision is based on security policies that you configure, okay, on the device. And we're going to get into that. And we're going to go through how to configure those policies and how to understand what these zones are doing. So some of the core security features, we talked about the firewall, the stateful firewall capability, VPN, NAT, application layer gateways, intrusion detection prevention, and screen options. These are all standard capabilities of the Juniper SRX device, will be built in. Okay, so control plane versus data plane. We haven't looked at this before. So the control plane is where our routing engine was implemented on the routing engine, or if you've got multiple routing engines, implemented on the multiple routing engines. The Junos kernel, processes, the chassis management, user interface, routing protocol, system monitoring, and clustering control are all configured and managed and controlled within the control plane. The data plane is implemented on what's known as IOCs or MPCs, depending on the device actually, SPCs, and implemented on the smaller devices, like the little ones, is implemented actually on the CPU or the MPU, and PIMs for the branch platform. So what we're saying is that if you've got a very big device, very large SRX device with lots and lots of ports, typically what happens is, if you want to add some more ports, you get a card and you plug the card into the device, and voila, you've got some more ports. So when in that situation, the actual processing capabilities to process the traffic that is associated with those ports is built into the card. So as you add more cards, you add more ports, you also add more processing capability into the device to handle that extra traffic, which is actually an important consideration. If you're looking at a device that you're thinking of expanding, it's very important to understand that if I do expand this device, am I going to be just putting more and more load back on my central processing, or actually am I adding more processing capability as I expand it, so that as I expand it, my processing capability expands along with it. Okay, so the forwarding packets, so in the data plane we're forwarding packets, session setup and maintenance, load balancing, security policies, screen options, IDP and VPNs are all implemented within that data plane. Okay, so let's take a look at the logical flow of traffic through our SRX device. Let's just take a look at what happens. How does this work? So a packet comes in on an interface. So here we have our packet ingress. Packet comes in. The usual, we can apply the usual things to a packet. We can have a policer, we can have firewall filters, we can have shaping, we can have all that happening on packets as it comes in. So we can still apply a firewall filter to an interface, just like we could before if you need to. Mind you, a firewall filter is stateless, right? It's just a basic stateless filter. We can still put that onto an interface if you want it. Then what happens next is it goes up into this flow module. So the packet comes in and it goes in and it gets evaluated to see, does this packet match an existing session? So have I already got a session that is coming from an address to an address with a protocol using port numbers that this particular packet is also using. If the answer is yes, then it goes through this fast path processing. We apply screen options. We're going to be doing we're doing natting if we need it. We're going to set up an application layer gateway if we need it, and it's going to go through that fast path. If we look at that particular packet and we say, actually, that doesn't match anything else that is currently happening, so it's a different source of destination address, maybe a different protocol. So we know it's different to everything else that's happening on our particular firewall. Then in that case, it goes up into this first path, because what we've got to do now then is we have to create a new session for that packet. Okay, so it goes up into this first part. And what we're going to do is we're going to evaluate the screen options. What are screen options? We'll get into this in a bit of detail, but just quickly, it looks at the packet and says, does this packet look suspicious? Are we being hacked? Okay, are we being hacked? And of course, if we are, then that's the end of that. That packet doesn't go any further. Then we say, well, do we have to do destination mapping on this packet? Do I have to change the destination address for this packet based on my natting rules that I've got set up on my device, or that you've set up? So you've set up on the device. Okay, so yes or no. If it is, then we do that. Okay. Then we're saying, okay, let's do a lookup. Let's see, do we have a route? Can we route this packet? Do we have information in our routing table that tells me what to do with this packet? Can I forward this packet? Looks in the routing table and says, yes, do I have an entry? If I do, great, continue processing. If I don't, drop the packet. Well, we can't route it, just drop it. It gets dropped. Okay, let's take a look then at looking at the zone. So we're evaluating, we came in on an interface in one zone, it's going out on an interface in a different zone. Okay, what are my policies in relation to traffic that's coming from that zone to that zone? Look at those policies. Is this particular packet allowed by those policies? If it is, we keep processing. If it's not, we drop the packet and the session is never created. Let me look at source NAT. Do I have to source NAT the packet based on our natting rules? Do I have to set up a application layer gateway for it? And then we go ahead and if all that is good, once all that is processed, we then create a session. So the session token is allocated and the flow or a session is added to our session table. So we now have permitted this traffic to go out, and we've also set up a session to allow then the return traffic to come in for that particular communication flow. And then the traffic is then forwarded out, eventually out to the egress interface. Okay, so one of the things to note there is that the very first time a new connection is made, it will take a little time to set up that connection. Now, it may be not even noticeable. You may just say, well, let's open up a page to a website. The router's going to do all that stuff to establish a connection to that particular website, or firewall, I should say. They'll do all that to establish a connection to a particular website. So it's probably going to be not even noticeable. Just open up, bang, bang, the connection will be established. Because we'll go through this first part, and then all of the traffic that's part of that connection will just go through the fast part. So, but there is a little extra processing to do when the very first connection is made. I will just sort of make a little bit of a point here that if that becomes noticeable. In other words, if you're saying, well, let's open up a connection to a new website, and I'm waiting for that connection to get going. Okay, oh, now it's working. That's probably an indication that your gateway device is getting a little overloaded with traffic. Okay, in other words, you may be looking at a situation where maybe I need to upgrade this device to something a little more powerful because the amount of traffic I'm hitting it with it's sort of starting to get to the point where the processing mechanisms are struggling to get these sessions set up fast enough for what I need within my organization. So that's just a little bit of something to watch out for if it is taking a long time to set up initial connections. I have seen it happen, particularly if you're running a lot of services, you're running screen options, you're running IDP on it, and maybe you're running some other things. Maybe you're running some content filtering and other things on it as well. You can actually load a lot of stuff onto these devices. And you can get to the point where you get really ambitious, you want everything on it, and you end up sort of stressing it out. You can actually notice that. Alright. Alright, so what we looked at is how a packet sort of comes into the device and the general sort of flow of it as it goes through, where it gets first of all evaluated as does it match the existing session. If it does, it goes through the fast path. If it doesn't, it goes through the first path where we actually set up the session and set up the return traffic for that flow. Okay, so let's look at session-based versus packet-based. So session-based mode tracks session information. We use this criteria to determine whether the packet belongs to a session: source address, destination address, source port, destination port, and the protocol. We perform fast path processing for an existing session. However, packet-based mode does not track session information at all. Okay, so with packet-based mode, so it comes in, looks at do we have any polices, do we have any input filters. Let's do the lookup, and out we go. Very, very fast. So it is stateless. Bypasses the flow module altogether, and we don't use any of those security capabilities at all. As I said, we've been using this device in packet-based mode all the last term. We're in packet-based mode. We were just really setting up routing, looking at how routing works. This term, we're going to be using it in session-based mode. Okay, now it is possible to actually, particularly on our branch office type devices, to actually identify some traffic and say, well, I want this particular traffic to be flow-based, excuse me, and I want other traffic to be packet-based. It's actually possible to set up both, or to have both happen simultaneously on the same device. And the way we do that is you create a firewall filter to identify what traffic you want as packet mode. And this is an example of that. We say, well, all traffic that comes from the 10.10.1/33 address is going to be packet mode traffic. And then we just apply that as an input filter onto our relevant interface. Once we do that, the result of that is all the traffic. Oops, let's go back to the slide. All the traffic from that address will simply be diverted straight out to the egress interface. So it won't go through the session creation process at all. Why might we want to do that? Well, there may be some reasons maybe why we want to do that. It's really a more, I guess, efficient, less processor-intensive way of processing traffic. Here's an example of maybe why we may want to do that. If we are using an MPLS network, and you might look at that and say, what's that? We're actually covering MPLS next term, by the way. So I'm going to get into this in great detail. But essentially, what this MPLS is doing is it's creating a virtual private network using a carrier technology called MPLS. And if our particular branch device is participating in that network, we have these things called VPN routing and forwarding tables, or VRF tables, which participate in an MPLS network. And in that case, it would make sense to simply have packet processing for that. So what I'm saying is that, yes, it's possible to set up a different routing instance and just process that as packet-based, if you needed to. Okay. Alrighty. At this point, we might take a short break. Then we'll get into looking at session management. And then once we do that, we're going to move right into looking at zones. We're going to get into zones in a fair bit of detail, examine what zones are, how we use zones, what are the different types of zones, because the zone is one of the basic building blocks of our security functionality. So we're going to get into that. So we'll look at, first of all, after the break, we'll get into session management, look at how we can manage our sessions, and then we'll get right into zones. So let's just take a short break at this point.